36%. That was the 5-year survival rate for Australians and New Zealanders diagnosed with gastrointestinal cancer in 1991. Determined that this needed to change, a handful of researchers came together to try and improve these odds for their patients. 30 successful years later, that small group has grown to over 1,500 medical professionals, all united by a shared goal of creating a world free from GI cancer. The past 3 decades have seen some truly amazing developments made by our medical practitioners, community supporters and trial participants. Like the pioneering CO17 trial, which not only found a new effective treatment for bowel cancer patients, but uncovered how a patient's genetics can impact their survival. And our GAP trial's bold approach of putting chemo before surgery saw oncologists and surgeons work side by side, turning the standard pancreatic cancer treatment on its head. Or how we have improved survival rates for stomach cancer patients through our Integrate trials. And thanks to global collaboration and new discoveries, this trial continues to evolve and study more successful treatment options. Over the years, we've provided new treatments to more than 7,000 people across 59 clinical trials. But we haven't done it alone. Our community supporters have helped make our progress possible for years. In 2015, an inspiring group of fundraisers took on the first Gutsy Challenge trek, climbing Mount Kilimanjaro. Since then, they've walked nearly 9,000 kilometres and raised over $1.4 million to fund new GI cancer research projects. But our supporters don't all climb mountains. From the patients and survivors who share their stories to the generous donations given. Without them, we would not be here today. Ultimately, it's more than dollars and research. It's about real people with real families. Like biliary tract cancer survivor Raymond Yong, who has been given an extra 10 years to see his 3 children grow up, thanks to the TACTIC trial. Or Sarah McGoram, who at just 18 was diagnosed with a rare GI cancer and given 1 year to live. Yet 25 years later, clinical trials have kept her not just alive, but living. Yes, we've come a long way, but with GI cancer still claiming the lives of 47 Australians and New Zealanders every day, our work is not done. Thank you for being an important part of our journey as we look forward to the next 30 years together, creating a world where 47 deaths a day become 0.
Good evening, everyone. It's a pleasure to be here and a pleasure to welcome you all. My name is Dr. Shalin Naik, and I'm a group leader at WEHI, formerly known as the Walter and Eliza Hall Institute of Medical Research, and also an occasional TV host of documentaries on the ABC. I'd first like to begin by acknowledging the traditional owners of the country throughout Australia and recognise the continued connection to land, waters, and culture. We pay our respects to their elders, past, present, and emerging. So why are we here today? 28,600 Australians are diagnosed every year with a gastrointestinal cancer, and 39 die every day. GI cancers are all connected to the digestive system, and so they include those of the esophagus, stomach, liver, gallbladder, biliary tract, pancreas, large and small bowel, rectum, and anus. Survival rates for those diagnosed with GI cancers are lower than for other well-known cancers, like breast and prostate, with survival rates of over 90%. Unlike for those, there's only a 51% chance of surviving 5 years with GI cancers. These are overwhelming numbers, and that's why for 30 years, the GI Cancer Institute has been raising awareness and funds to support clinical trials to improve treatments and survival rates for people with GI cancer. Today, we're here to discuss the current landscape and challenges facing cancer research in Australia. We're going to hear about cutting-edge new GI cancer research and learn more about the impact a diagnosis can have on someone and their family. So a bit of housekeeping. Look, please feel free to submit any questions you have throughout the webinar, and we will answer them during the Q&A session towards the end of the session today. So just click on the Q&A button at the bottom of your screen on the Zoom page. It's to the right with a couple of speech bubbles, and we'll be able to answer your questions. So it's my pleasure to welcome and introduce our guest speakers today. So first up, I'd like to introduce Professor Dorothy Keefe, who has led Cancer Australia, Australia's national cancer agency since 2019. Prior to this, she had a long and distinguished career as a medical oncologist at the Royal Adelaide Hospital and as Professor of Cancer Medicine at the University of Adelaide, where she remains an honorary clinical professor. Her long-term research interest is in supportive care in cancer. Good evening, Dorothy. How are you this evening?
Good evening, Shalin. I'm very well, thank you, and delighted to be here. Thank you very much for inviting me.
Absolute pleasure. And second, I'd like to introduce Dr. Lorraine Chantrill. She's chair of the GI Cancer Institute and senior staff specialist medical oncologist and head of service for medical oncology across the Illawarra Shoalhaven Local Health District and area clinical director of clinical trials. Dr. Chantrill treats patients with any cancers of the digestive tract, as well as gynecological cancers and lung cancers. Lorraine, how are you this evening?
I'm very well, thanks, Shalin, and I'm very pleased to be here. And I'm very grateful to all of you for joining this webinar this evening so that we can hear your concerns and hopefully answer your questions. So I'm proud to come to you from the Dharawal country of the Wadi Wadi people in the Illawarra of New South Wales.
Fantastic. Thank you, Lorraine. Next is Jeff Cuff. He's a carer and GI Cancer Institute Consumer Advisory Panel member. Jeff has been focused on cancer research, in particular colorectal cancer, following the death of his wife from colorectal cancer 8 years ago. He is a member of several cancer research organizations, including the advisory panel with the GI Cancer Institute, CONCERT, previously the TCRN, the Cancer Council of New South Wales, and the Walter and Eliza Hall Institute, where I'm from. Good evening, Jeff. How are you?
Very well, thank you. And it's a great honour and pleasure to be here and discuss this very important subject. And I'm looking forward to the evening. Thank you.
Thank you, Jeff. Looking forward to hearing from you. And last but not least, Professor Rob Ramsey. He's co-head of the Gastro-Intestinal Cancer program at the Peter MacCallum Centre. He's also the head of the Differentiation and Transcription Laboratory at the Peter MacCallum Cancer Centre, chair of the GI Cancer Institute Translational Research Committee, and member of the Scientific Advisory Committee. Professor Rob, how are you this evening? Nice shirt. Oh, you're muted. Classic.
I'm great, thanks, Shalin. I'm really pleased to be here. This should be lots of fun, lots of information, and I'm really pleased you're hosting it.
Brilliant. Well, thank you. Righto. Let's get into it. Look, I'm going to first ask Jeff to speak. Jeff, look, the reason why we're all here today is to improve the lives of patients and outcomes for families impacted by GI cancer. So we'd be very grateful if you could share your story and your wife Shirley's story from diagnosis onwards, and what motivated you really to start this foundation.
Thank you. Well, our story and the journey since then started in December '09 when Shirley was unexpectedly diagnosed with colorectal cancer. And up until that point, she'd been quite a fit, robust person. So it came right out of the blue that she was not only sick, but she was very sick because she was diagnosed with stage 4 colorectal cancer. So that December, Cheryl went straight in for a resection. So it was a very different Christmas. She came home for a short time that Christmas, but the same day had to go back into hospital. Cheryl went through a whole range of treatments, including chemotherapy. She had ablation. She had embolization of the liver because at that stage it was thought maybe a resection of the liver would be successful. And she also had internal radiation, spheres, or zerts. And Cheryl was very bold, and she wanted to try everything. She wasn't going to not give it a go if she thought that it was going to be useful. And that was her attitude right throughout the treatment. At about that stage, I was asking the question, as was everyone really, is Cheryl on the best treatment? is it right for her? And at that point, it was agreed, including with Cheryl, which I think is important, that some more biopsies were taken. And I sent them over to the US to a company over there, Claris, who did a full molecular profiling. And we got a result back in 3 weeks that suggested that the ideal treatment for Cheryl might have been a drug that was actually quite toxic. So it occurred to us that if we knew information like that earlier, then it would be a good thing to actually direct the best treatment. And I was always interested in biomarkers and what they might mean in relation to deciding what the best treatment for the individual was.
So biomarkers being these telltale signs in some tumours, and they might be different between different people and different between cancers, to give you information on how to treat them.
Yeah, the drivers of the tumours. And
yes,
at that stage, if you had the ERCC1 biomarker, then maybe you wouldn't give a platinum-based drug, but I think that's since been dismissed. But the point was, it was a point of information that surely would be useful for treating patients. And that started my interest really on personalised medicine. So while Cheryl tried everything, unfortunately, we lost Cheryl to colorectal cancer on the 20th of July, 2013 at home. Cheryl stayed here and she passed away at home with the family around her. After that, and when I'd gathered my breath, I travelled around the country to a lot of major research facilities and asked the question, what are you doing and why are you doing it in relation to colorectal cancer, in particular, questions around biomarkers. And I finished up at Walter and Eliza in Melbourne. Initially, structural biology were away, but I was invited back and very fortunately for me, met a Professor, Tony Burgess, who immediately seemed very inclusive for me and invited me into the laboratory. We talked about it, and that started a long-term relationship that exists today. Initially, it was on the APC gene that he was looking at, but then it sort of moved into the use of organoids and tumoroids to better depict and align the best treatment for the patient outside the patient, so that we knew before you could ideally reach off the shelf and pick a drug that, from a genomic point of view, looked like it was going to work well for that. So just
to cover it, these organoids and tumoroids are little mini versions that you can grow in a dish and therefore test lots of different things on it to see what works against that tumoroid, as it were.
Correct, that's right. So the idea really was, and because the colorectal cancer, as I understand it, is quite heterogenetic, as it moves through, it changes, and perhaps the ideal treatment later is different from the initial primary cancer. Yes. So after that, the research down there I became very involved with, and I was on a steering committee for that research now, which I think is great, and I think it's going to lead to really progressive things in colorectal cancer, or any cancer really. I became involved in, at that point, it seemed very obvious that research was very poorly funded. And at that point, we started and launched the Shirley Cuff Cancer Research Foundation, which is that. And it supports primarily at this stage colorectal cancer. And it is going very well, other than with COVID and so forth. It slowed things up. I'm a member of quite a few other groups, and I really want to emphasise the AGITG because I became a CAP member there on their panel, and that has been great because it's really enabled me and others like me to see a lot of research, both young and more advanced research, young researchers and established researchers, and it enables you to understand what the research is about and where it's going, and to contribute to that research in some ways. And I'd have to say the researchers that are involved in the AGITG programs, research programs, really listen to that CAP program and take advice from it. So it's an excellent opportunities for people to get involved and contribute to the direction of research in the GI area. As you mentioned, I'm involved with the TCRN, which is now the Sphere Group, and the Cancer Council, and both New South Wales and Australian. And I've been on some working parties there into colorectal surveillance and also the pathways for colorectal cancer. More recently, within that, I'm on about 10 AI projects, and it's just great to see a sort of like a cross-pollination, if you like, of research across many areas of different forms of cancer in the GI area. More recently, I was invited into a lab at UNSW, where I've been consulting for a while, and the professor in that lab invited me in to actually do some research myself. It was mainly on endometrial cancer and liver cancers. I went down and spoke to Tony in Melbourne, who I kind of feel as a mentor. When I came back, I said, yes, it would be great, even though I was nervous, but I said, can I look at colorectal cancer? So he said, yeah, that'd be great. And we established a collaboration between Walter and Eliza and UNSW. Walter and Eliza sent up to me 3 different colorectal cancer cell lines, and we've been working on those. It's based on a new molecule. And essentially what I was trying to do is use that molecule with to build the effectiveness of some drugs like 5-FU, oxyplatin, the BCL2 inhibitor I used as well. And most recently, a lab in the Faculty of Medicine 6 weeks ago said, would you like to come in and do some work with us? So the project there, if it's not stopped by COVID, it will be on colorectal cancer pathways, signalling pathways and the impact of ROS. So I've been blessed right through this in having people that I can collaborate with and have helped me along the way, such as Tony, Carl, John Locke, and Rob on the panel as well has helped me a great deal. So it's been a great journey, and I look forward to it continuing.
Well, it's quite an inspiring story, Jeff. And look, you know, I think not everyone who's involved in cancer, or as a survivor or a carer, needs to get on the bench. But that is quite an inspiring story that you're getting on the bench and doing some experiments with us. Just extraordinary. But I think the message there is getting involved, having those conversations.
Yeah.
And I think scientists are increasingly open. It's not just we want to hold up these fortress walls. We want people to come in to see what we're doing, to have those conversations, to make sure that our interests are aligned here and that we're doing the right thing by you and your families. So thank you very much for sharing that story, Jeff. That's quite extraordinary.
Pleasure.
On that note, I think it's probably worth, Jeff touched on funding there in terms of, trying to find ways to fund research, the cutting edge treatments. So I'd like to bring in Dorothy Keefe now to cover the current research landscape and ecosystem, and to understand where the government priorities are, such as, in particular, improving equity of access for indigenous and rural patients. So Dorothy, where does GI cancer sit in terms of research and funding priorities here?
Thanks, Shalin. I think this is going to be quite a complicated matrix to discuss, really, because as you know, there are all of the different tumours and then all of the different stages of the cancer research spectrum to be looked at. So roughly, there's about 150,000 patients diagnosed a year with cancer. And you were saying at the start that it's somewhere around 30,000 that are GI cancers. So that's 20%. Now, in the latest look we've done at funding for cancer in Australia, actually the funding percentage that's going to GI cancers is not that high. So we think we at Cancer Australia actually perform every 3 years a review of cancer funding to actually answer these questions that you're asking. And we've just completed one which is unpublished, but in the last triennium, about $2.1 billion was spent on direct cancer research, which is a large increase, let me say. And actually, the vast majority of that is government funding through things like the NHMRC and the MRFF. But the proportion that goes into GI cancer is only, it sort of teeters between 16 and 20%. It goes up and down a little bit. In absolute terms, it's going up, but in absolute terms, so are some other cancer fundings. But I think it's very important for us to say that my philosophy and the philosophy of everyone in this area, when they take a step back, is there is no person with cancer who is any more or less important than anyone else with cancer. And they all deserve to have the same good outcome. And if you just, as we keep saying with, the disadvantaged, if you just do the same things for the disadvantaged groups, you don't get equity of outcome or justice really of outcome. So we also know that the rates in disadvantaged people are higher for many cancers. I was looking earlier today, particularly at pancreatic cancer, one of Lorraine's, top tumours. And while if you just do a sort of quick unadjusted look, it looks as if Aboriginal and Torres Strait Islander people might have less pancreatic cancer than a non-Indigenous population. But if you do proper age adjustment and take into account the age spread of our Indigenous population being different from the age spread of the non-Indigenous, it turns out they actually have more pancreatic cancer. Now, there's a thing that we actually need to do something with.
Yes.
So it's really important for us to look at all of those issues, and then to look at what actually happens in terms of which bits of cancer you're researching. So funding has changed over the decades between the biology of the tumour and the treatment of the tumour. And over the years, there's been a reduction in the biology fund, just pure basic science funding, and an increase in diagnostic and treatment funding. But that's probably partly to do with actually what Jeff was talking about, the druggable targets that we actually look at. So people don't go into the lab now and say, I'm just going to do research into targets. They actually want to find a druggable target that they can actually influence the outcome with. And so that moves it into the treatment phase. And all of these targeted therapies, immunotherapies, precision personal medicine has changed the area there. There are still some areas that we're not very good at researching. They obviously are not, either they're not attracting people to put in grants, or they're not reaching the standard to receive the grants. And again, we use this analysis every triennium to reshift the priorities. And right. Cancer Australia has its priority-driven collaborative cancer research scheme, and the priorities for that are set by the needs based on what's been done before.
So would it be fair to say, you're mentioning how there's been a transition from sort of the discovery to the application? Is that sort of like learning the rules of the game of how cancer operates, and then trying to actually play that game in terms of trying to find a way to knock it off? And so finding these biomarkers, as Jeff was talking about, finding ways to take these nitty-gritty molecular profiles of cancers and say, well, okay, we understand how this works. Now we need to find how to knock it on the head and really do that well.
Look, I think that's fair. I mean, I think in cancer, the aim of the game, the goal, is survival with good quality of life. And I note in the questions there are people talking about how bad the toxicities are of treatments, and of course that's an area very close to my heart. So there is this thing about what we're trying to do is have people live the longest life of the best quality, and so we have to actually, it's applied science. We need applied science to enable that to happen.
Yes. And I guess it's also worth mentioning that there are some research endeavors that will apply to many cancers, not just one or the other. And so we can't forget about those. So things that might reduce toxicity for a given family of drugs reduces them across the board.
That's a really good point, Shalin, actually. And I think it'll give me a chance to plug this other piece of work that we're doing at the moment, which is developing an Australian cancer plan.
Mm-hmm.
It's the first time Australia will have had a national plan. And we're saying it's tumour agnostic. Well, of course, it isn't really tumour agnostic. It's just that it's got every tumour in it.
Right.
And what we're trying to do is
tumour inclusive.
That's a much better word. Tumour inclusive. And what we want to do is make sure that the things that are the same for every tumour are managed as a single thing, and not this, so we don't waste with duplication. But
Yes.
for every individual tumour, we focus on the bits that are really specific for that cancer. And there are things that are really specific for different GI cancers. Esophageal cancer has, eating issues, and it's, and various bits of bowel cancer have issues to do with body image and also feeding. And, so there's a lot of different things that you have to look at. We need to make sure that we do actually consider all of those things that are specific to those tumours and research on those.
Yeah. So look, that's really encouraging to hear, because like it or not, funding is always finite, no matter what we would prefer to have in reality. And so by being able to not double up on resources and try to find common threads that can be tackled, not forgetting the unique aspects, I think that's just the approach we have to take, isn't it?
It's a pragmatic approach that enables us to spend the money wisely.
Yeah. Look, Professor Keefe, thank you for describing what it is you do and what your analysis looks like in terms of setting priorities and giving advice. And I think we can all value the importance of that, to adding to that holistic approach that we're seeking here. So thank you so much for that. I will now move on to talk to Lorraine Chantrill. Lorraine, look, we'd love to hear about the progress that have been made for GI cancer specifically, in terms of improvements with colorectal cancer treatment and screening, personalized treatments. What is personalized treatment? What does that actually mean? And quality of life. We've touched on toxicity. What does it mean in real life terms? And what are the things that are happening in this landscape?
Thank you, Shalin. And I would have to say that I'm very proud to be part of this organisation, which is now 30 years old, in running clinical trials for people with gastrointestinal cancers. And we have made some fantastic inroads into treatments. So one of the examples that was mentioned in the introductory video was an example in colorectal cancer, where we were part of a study that looked at certain molecular markers of colorectal cancer, and was one of the first studies to show that the RAS genes influenced response to treatments with some of the antibody treatments which we now use. And we're very proud that it was Australian researchers who were the first to show that those RAS mutations meant that people would not get a benefit from the EGFR inhibitors. And that was very, very important, because it enabled us to find a test to predict response for a treatment. It also saved a lot of money, because instead of giving everyone a treatment that only works for a proportion of people, we're able to select ahead of time those people most likely to get a response from a relatively expensive treatment. And that's, I think, really the principle of personalized medicine as we go forward, is to find targets within cancers and to test the drugs that can target those, and make sure that they work well and that they do improve length of life, and, as you said, preserve quality of life. And we do find that for the most part, targeted treatments do preserve quality of life, because there's less scatter, there's less other side effects, generally speaking.
Yeah, so targeted therapies, maybe we can just kind of capture that for those who might not know. Targeted therapies are, instead of a big giant sledgehammer, they're trying to get down to the nitty-gritty of a particular cancer so that the collateral damage is much less. Would that be fair to say?
Exactly right. So chemotherapy works by affecting fast dividing cells, and so it's not very selective. It's a bit selective because cancer cells divide faster than other cells in your body, but it affects other cells. Whereas these targeted treatments, take for example cetuximab and panitumumab, that target the epidermal growth factor receptor that sits on the surface of the cell, they're actually blocking that target, so preventing cell growth by doing that. So that's why they work well. They're selective and they have less side effects than chemotherapy, yes.
Right, so what we're hearing is that for the saving of money, fine, that's very important, but most importantly, no drug has no side effects, none. And so what we want to do is make sure that we're only giving the right drugs to the right people where we can hopefully, get a good prediction that it's actually going to work and spare people for whom it's not going to work, the heartache, the hospital stay, etc. And then as we move to more targeted therapies to reduce those side effects, hopefully to nothing one day, and each person who might have a slightly different biomarker to tailor that response to their needs.
Exactly, but I think we also have to do things for the people who have to have chemotherapy where there isn't a target.
That's right.
And we actually do have a clinical trial running at the moment that's been designed and led within Australia called the OxTox study. And it's looking at the toxicity of a very commonly used chemotherapy in bowel cancer called oxaliplatin. And it's repurposing an oral medication to try to prevent peripheral neuropathy. So that's damage to the nerves in the hands and feet, which is a very common side effect of that drug. And in fact, a dose limiting side effect, so that people can't have that drug forever because of that. So we're really embracing improvements in quality of life. And I think we listen to our consumers. Jeff, who you've heard from, is one of our consumers, and we ask them all the time, what are the trials that you would really like to see done as a consumer? And it's very important, I think, to ask people with a lived experience of cancer what they want, what their needs are, and what they value most highly. Professor Keefe talked a little bit about access, and I think it's one of the things that we need to do better is to make sure that we improve access to clinical trials to people everywhere in Australia and New Zealand, not just to people perhaps who are in cities. So that's one of our goals in our plan for the next few years, is really to ramp up access outside of our cities and to target disadvantaged groups who have not had access before. And we will be, and we are, consulting with people who come from some of those disadvantaged groups so that we can do that properly.
Right. Are there any real world examples you could give us to help us understand, how in concrete terms this has, some of these efforts and endeavors have changed a person's life who might have slipped the net, or might have got something they otherwise shouldn't have, or got something that they didn't know existed and should have?
Yeah, so I think there's lots of examples, but I might just talk about one from my own patient cohort, a man who's receiving treatment for a rare cancer called a neuroendocrine carcinoma. And we have a trial that uses a combination of chemotherapies, but the chemotherapies are kind of a little bit kinder and perhaps more effective than the old-fashioned chemotherapy that we used to use for that cancer called carboplatin and etoposide. And this particular man has had an amazing effect of the treatment. He's done really well, certainly improved his life expectancy, but importantly improved his quality of life. And he's very happy to have been on a clinical trial. So that's just one example, but I don't want to steal Professor Ramsey's thunder, but he will talk about some of our other success stories about looking at circulating tumour DNA to predict for cancer recurrence, and trying to improve the selection of patients for either very aggressive treatment or less aggressive treatment, depending on that. So that we're looking forward to seeing those studies report over the next few years.
Wonderful. Well, look, that's probably a good opportunity to now throw to Rob. Thank you very much, Lorraine.
It's okay.
So Rob, circulating tumor DNA, liquid biopsies, are they the future of diagnosis? What is the future of diagnosis prevention look like now? What are these new developments look like?
It's a very hot area. Lots of things are going on across lots of different tumour streams. I'd have to say that GI cancer is probably leading the fight at the moment, or the journey. Some of this work is led by one of my colleagues at Peter Mac and at Walter and Eliza Hall, Associate Professor Jeannie T. She's been working on a project called, there's a series of clinical trials. They're all called dynamic, and they've got numbers 1, 2, and 3. And they are seriously exciting, because if you can understand the nature of the primary tumour or the starting tumour, there are fingerprints or a footprint about what's going on in that particular tumour. And that's encoded by the DNA. If they have, you've heard this a little while before, RAS mutations, they're specific, there's a sequence. We can amplify it using the same kinds of technology we're using for COVID testing. There's a polymerase chain reaction. It's a very sensitive technique, and it has the capacity to identify the presence of a tumour based upon the breakdown of the tumour as it's disintegrated in the primary site, circulates around in the blood as fragments, and we can capture those fragments and amplify them and identify, yes, there's a mutation there. So this is the scenario. You have a patient with a tumour that we can biopsy. We do the molecular signature of that. We identify things which are peculiar or specific to that tumour, and the patient is treated. And with, typically a good outcome would be the tumour goes away. And correspondingly, the amount of circulating tumour DNA associated with that tumour also goes away. However, as we also know, patients do relapse and the tumour comes back. So the circulating tumour DNA is faster at picking the relapse than any other modality we currently have. Noting that we're still doing the clinical trials and there's lots of validation, but the picture is pretty clear. It's faster, it's more accurate, and in addition, we can identify new things which are arising in the re-emerging tumour that will give us clues about what other treatments we might apply. So the quicker we identify a relapse, the quicker we can stop treating with the drugs that we might be maintaining or maintenance treatment. We switch drugs, and then we identify what's the next best therapy that you might employ. So that dynamic trial is something that AGITG, the GI Cancer Institute's been supporting. It's internationally recognised. It's run by gun researchers that are connected all across the world. In parallel with that, there's another trial going on by another one of our colleagues at Lehigh, Professor Peter Gibbs, which is called the Forecast trial. So you can imagine these things can run in parallel. They're not separate, they're connected in principle. And what that trial called Forecast is doing is we can now remove a piece of tumour from a patient as we go through the molecular pathology and the basic pathology. As Jeff was talking about, we can grow organoids or tumoroids from those, put them into an assay to identify, are they sensitive to the spectrum or the portfolio of drugs that we might employ, including the one that is being employed first up. We can identify whether that tumour is now sensitive or not to that particular drug. The advantage of that particular approach is that we might change the treatment of a patient before we can recognise the patient is not responding to the drug. So there's a window of time, let's say typically 2 or 3 months, where the medical oncologist will be treating a patient in the expectation that on average, that's the best treatment. But average is not good enough in personalised medicine. We want to have specific information about a patient. And with these sorts of approaches that Peter's taking and many of the other research community are taking on, we can say, well, okay, we could have told you that patient wasn't going to respond to that drug, but previously we had no technology to do it. So right. Peter, think about changing the drug. And he'll say, well, which drug? And Peter's got a spectrum of available drugs that you could apply in those patients. And we say, well, maybe instead of oxaliplatin that Lorraine was talking about, use gemcitabine or use irinotecan. These are just names of drugs, but the key thing about the drugs is they work differently. And we don't know which one to go in first. It's like having an army and you don't know which lot of soldiers to put forward first who are the most skilled at fighting the battle you want to do. So this is a really immediate opportunity to translate lots of things that have happened in the lab over the last 20 years to have an immediate impact upon what might be happening in the patient. So we can turn that assay around in 4 to 8 weeks. Remember that window of time that the medical oncologist is in the dark about our responses, that 2 to 3 months, it's compatible. In the past, we'd often be able to tell the medical oncologist, we told you it wasn't going to work, but sorry, it took us 6 months to do the sequencing and another 3 months to do the analysis. And we told you it wasn't going to work. Sorry, we're too late. That's the problem. We've got to be nimble on our feet, respond as quickly as possible, using technologies which are translatable in the real world in a cost-effective way that gives everyone confidence to change the drugs.
Right. So, what I'm hearing is that for these 2 examples, the first example, this liquid biopsy, you take a bit of blood and it's these DNA fingerprints in there that give you a window into the soul of the tumor without having to go into the tumor itself. And that can already inform you about which other treatments might be useful.
Yeah.
So that's highly informative. It's like a predictor. Here's things that certain drugs might be able to act upon. And then the forecast trial is saying, let's create these little mini avatars of the tumor in a dish. Say, well, we've only got 1 patient to treat with a drug, but why don't we create thousands of little avatars of that tumor and try different drugs off to the side, see which one works, and then go to the patient. And these are, just incredible developments from a scientific perspective, but also real world effectiveness in terms of patient outcomes.
So the first really robust assay or technology to get those organoids growing was around about 2009. And my lab works in that space. And I remember I was actually doing a sabbatical in Paris at the Curie Institute. So I was spending a lot of time reading the literature, and this stuff came out of Hans Cleaver's lab in Utrecht. And Hans has been a guest in Melbourne many times. He did a sabbatical at Lehigh. So they got the magic cocktail. It isn't really magic. Science isn't magic, but it felt magic because we've been struggling to do it. And progressively, we've all developed the capacity to grow these organoids reasonably efficiently. And they are turning out to be better than any of the other models that we've used to predict responses to drugs. In addition, you can start mixing and matching. And this is where some of my own research comes in and others is we can bring in other parts of the equation that I'm particularly interested in. That's the immune system. We can say, can they work together? And we really didn't have that capacity before either. So we know that the immune system is a major arbiter of the responses to all the other armory we use for our patients: surgery, chemotherapy, radiotherapy. If the immune system is robust, all those other modalities work better. And we need to understand those things in functional terms. So let's track back maybe 10 years ago. We had the promise that if we sequenced the cancer genome, that is, we knew what the DNA had, all the parts, we could predict responses to drugs. That's partly true, but frequently not true. So the organoid technology is allowing us to do functional assays to say, well, we predicted it would be responsive to this drug, but we can test it in real time before we put it in a patient. And on occasions it doesn't work, don't use it. And that's, I think this was touched on before, using something that doesn't work in a patient is something as important in my mind as using something that does, because all the drugs that we use, particularly the ones we use in cancer, as Lorraine explained before, they have quite severe side effects. And it's a balance. It's a game between benefit and cost. And why do any harm if you don't have to?
Exactly. No, I think that's a really important point. And Rob, really great and interesting insights into the into the innovations, I guess, we're seeing in how we diagnose patients. It's not just looking for a couple of things and, trying this, one approach that works on average, as you were saying, but really trying to get to that finesse of that approach to make sure that, the quality of life is maintained and that people get the right treatments and get them quickly.
I think the message is average is not good enough anymore.
No, it really is not. We're not averages. We're not big
No.
smoothies of humans. We're all individual with our individual characteristics, and the same goes with, unfortunately, the ailments that we suffer. So thank you, Rob. I think at this stage, what I'm going to do is bring the panel back together and start answering some of these questions that have come up in our feed. So thank you, everyone, for submitting your questions, and please continue to do so. I'm going to basically go from the top here and, start off with a question from Libano Diaz. Maybe we can ask Lorraine this question. What is the difference between colorectal cancer and colon cancer?
Yeah, we seem to use those terms a little bit interchangeably, I guess, which is a bit bad of us. But colorectal cancer just means it's the colon and the rectum, and colon cancer is the colon. The two are connected, but rectal cancer is treated a little differently. We generally involve radiotherapy in the treatment of rectal cancer, and generally speaking, we don't do so in colon cancer. A good word to use for both colon and rectal cancer is bowel cancer. So when people say bowel cancer, they mean either or both.
Right. Yes. It's just a case of terminology, but actually from a science level, there's a relatedness of those two tissues that mean often the cancers are similar in how they form, but also how they can be treated. Would that be fair to say?
Absolutely. So in the case of advanced or stage 4 or metastatic colon and rectal cancer, they're treated pretty much the same. But in the early stages of the disease, they are treated a little differently.
Yeah. I see. Wonderful. Thank you. Look, my next question is from Padmanabhan Karamil. Maybe I'll ask Rob this question. Generally, do you collaborate, and maybe also Jeff, actually, from your experience, do you collaborate with research elsewhere, both within and outside of Australia, so that synergy is achieved and limited funds are most efficiently applied? I think that's a really important question. So I'll ask you first to answer, Rob.
Of course, we collaborate as widely as we can. We picked people to collaborate with on basis of two things. One is they're hopefully the best at what they do, and also that you can work with them collaboratively and it's enjoyable. It's a hard slog doing research. You want to work with people you trust and enjoy working with. So as a real life tomorrow example, we have a Zoom meeting, of course, everyone having a Zoom meeting with people from the Utrecht lab in the Netherlands to talk about some anal cancer work. So that team in the Utrecht are by far the international leaders in this space. We've had a lot of success with a particular kind of cancer called squamous cell carcinomas. So we're going to team up together. We'll put in an international application. The combined grunt of our track records and our experience will probably deliver something more powerful than we could do independently. And you're always better off in a team. It's much easier to kick a goal if you've got someone feeding the ball to you, and it's also important that you've got all the support structures. And we're very fortunate in Melbourne in particular to have those sort of connections, but we also have connections. There's a national consortium involving organoids right across Australia that's being driven out of Queensland. We're part of that as well. So none of us waste money. I can promise you that. We make the dollar stretch in a ridiculous way, and I feel that, and there's a metric for this, that for every dollar spent, it's between $3 and $7 return, depending upon the cancer stream. So the returns are great, but we don't waste the money, I can promise you. There's not many of my colleagues having the glorious life. They're too busy doing their experiments.
That's right. And Jeff, in your experience, from your observations, are you seeing researchers work together? And might there be more efficient ways we can have researchers work together from your perspective? You're muted. Sorry, Jeff.
Sorry about that. Yeah, definitely I see it in many trials that I look at or I'm involved with. And I think it makes such a lot of sense because trials are expensive if you're lucky enough to win a grant, but they're very expensive, and it just seems to make a lot of sense. And you see it now where people are collaborating with colleagues, not just around the country, but also overseas. And I think it's growing, and you've got centres of excellence that may have done similar work, and they say, well, look, we've already done that part, and we recommend that you don't need to do that. And these sorts of combined approaches to things, I think, make the research more efficient, more cost effective as well. So yes, it's a definite trend.
Wonderful. So the next question here is from Dan Kent for Dorothy. Public funding of medical and cancer research. He can agree that it cannot be proportional to incidence only, and mortality is also a very important metric there, as is the quality of research being proposed. How does a public funder determine the proposals to be publicly funded?
Thank you for that. Thanks, Dan, for that question. There are actually two different aspects to this. One is how you assess a research grant once you've received the research grant, and that relates to the peer review process and making sure that you've got quality reviewers and that everybody is, it's all checked and thoroughly quality controlled.
So peer review, for those who don't know, is basically sending it to our colleagues anonymously so that they can look at the science and judge, how does this compare to others? Again, because there's this finite pot of money and it needs to be distributed to the best.
That's right. But the other really important bit is how you make sure that the spread of money actually covers the spread of the burden of disease. Yes. And I think this is, within cancer, this is one of those sort of taboo questions, but I am going to brave it slightly with indulgence. So there are some very common cancers that have had a very, very good share of the proportion of funding and have got very high survival. There are also some less common cancers that have had less money invested over time and have less good survivals. Now, it's not a linear link that less money causes less survival. It's probably actually the other way around, that tumours that respond better to the treatments that we've been able to research actually do better and get more money. So there's a bit of a mismatch, but it is true. And in our latest look at the funding, which actually will be presented at COSA next month, so I can't sort of disclose too much of it, but it is true that some of the high burden cancers have less money. The biggest mismatch is lung cancer. The burden for lung cancer is huge, and the funding for lung cancer research, while it is increasing, is not very good. In something like, I think I've got the figures for pancreatic cancer. So pancreatic cancer funding increased from less than $1 million in 2003 to 2005 to $17 million in 2018 to 2020, which is actually quite a big jump. And we are currently, Cancer Australia, ably chaired by Lorraine Chantrell, who's pancreatic cancer maven, is developing a roadmap for pancreatic cancer, which will actually be ready by the end of the year and will include key performance areas where we need to look at research. So we've looked at the whole spectrum. We've looked at where the gaps are, where the blocks are, where the funding needs to be, and we'll be able to say, what needs to be done. And something like that will actually kickstart more investment because we will show the priorities. And once you've got the priorities in front of you, you'll see it and there'll be money. The greatest example of that as a rarer tumour with an awful outcome is brain cancer. Brain cancer's had $100 million investment through the Brain Cancer Mission. because it got some focus. So there is some rebalancing going on. Those very high outcome tumours are reducing their proportion of the pot, and the others that need to are coming up. It's a slow rebalancing process.
Yes.
You have to get the researchers interested in researching different areas, and you have to get the advocacy groups enabled to advocate, and you have to get government aligned. It's a long-term project.
Yeah, it's a tough game because speaking as a scientist, it's hard for us to switch fields at the drop of a hat. It takes years of reading the literature and understanding it in intimate detail before we feel ourselves confident to even give it a crack. We want to do service by the money we receive.
Well, that's right. But I think if you turn it around the other way and look at what the mechanisms are of the aberration, it's not so, it doesn't have to stick so much with one tumour.
That's right. That's right. All right. Well, thank you for that. And we're going to move on to the next question, which is an anonymous question regarding, and I'll ask this perhaps to Lorraine. In terms of access in rural and regional areas, can you talk about accessing Tele Trials?
Thank you for that question, because I think it's really important. And we've seen that COVID has taught us that we can do telemedicine, that we can do it safely, and we can do it with the good grace of patients and their families in those areas. So we have been running some Tele Trials. So, for example, we've had a prevention study of aspirin in people who have had sporadic bowel cancer, and that has been a successful Tele Trial model in New South Wales and in Queensland. Our Queensland colleagues are probably more developed in approving and using the Tele Trial model, particularly out of centres like Townsville, and they're really showing us the way. We also have some very active colleagues in country Victoria. So we're all learning how to do that better, and I think we will see a lot more of it in the future. We are relying on our regulators and governance officials to also come to the party with us to make it a little bit easier for us to do things electronically, like electronic consent of patients, for example. So we do need people to have open minds for us to be able to do these things as safely as we can. So absolutely, and it will be the future, I think. So thank you for that question.
Yeah, I think, as you say, COVID has completely opened up our eyes to the possibility, but also to the need of actually starting to do things a bit more remotely and still deliver high quality care.
Yes.
Right, I've seen a question here. Maybe we can ask Rob this question. Neha Gupta says, thank you for the info. We've spoken about treatment, but what is the cause of GI cancer? And what are the symptoms? So it's a big bucket of...
it's a big question, but I'll give it a
but
shot.
Broadly speaking.
So the interesting thing about the GI, particularly the bowel, is that the cells that line the bowel is extraordinary number, and they turn over very rapidly. The core functional unit in the bowel is called a crypt. And a crypt has a lot of cells in it, probably 500 or more, and it's driven by a small number of cells in the bottom called stem cells. I need to give you that information because it sets the stage for what I want to say next. So that crypt turns over every 3 or 4 days. It is beyond belief how quickly it replicates. The stem cells at the bottom are protected and nurtured to be kept in the most pristine state. You do not want to generate mutations in those cells. However, it does occur, and those cells, if they happen to have mutations, persist. And over time, additional mutations are introduced. And there's two parts of the equation. There's things called oncogenes or drivers, and there's things called tumor suppressors, which are the brakes. And to get a cancer cell going, you need to have someone putting, or essentially the accelerator's being pushed down and the brakes are being taken off. And all cancers in general have those principles running it. In bowel cancer, we understand is basically 5 to 7 genes commonly associated with change that lead to bowel cancer. And they are studied all around the world. They're well accepted. However, most cancers do not have all 7. They have a mix match. It's like getting a shuffled deck of cards, and you might get 5 in one pack and 3 in another, and that's the cards that you have to play with in that cancer. And that will dictate the responses that tumor has to all the drugs that we might apply to it, or the radiotherapy in the case of rectal cancer. So the major signs for bowel cancer, it's more common to be able to detect it if it's in the rectum or what we call the lower part of the bowel, because if there's a lesion that generates a change, it often generates some blood, and that's picked up by the fecal blood test, which all people over 50 in Australia receive in the mail, and that test works well to give you an idea there's blood. That doesn't mean you have bowel cancer, but it does give you cause to investigate further. Like most diagnoses, it's not based upon one thing. It starts you on the journey, and hopefully it may not be anything at all to do with bowel cancer. And then, of course, the more developed the investigation might involve a colonoscope, which looks up the bowel, where the gastroenterologist will identify the lesion. There might be taken out, pathology's done, and then the cascade of events happens. The analysis becomes more and more complicated.
Right.
We're good at it in Australia. Very good.
And in terms of, let's say, diet, are there, what are the you talked about the genes that get changed. What causes the genes to get changed? Is it our food? Is it toxins? Is it an unknown? Is it still under investigation?
I think there's
a combination of all the above.
I'm not prepared to say the jury's out. I think the jury is half convicted some of the parties involved. There's no question your diet influences your risk of bowel cancer. That's quite clear. Alcohol use, to some extent, tobacco use, and the real unknown in this game at the moment, which is extraordinarily exciting area, is the role of the microbiome. What I mean by that are the gazillion bacteria that are operating in the bowel, which is all part of your normal health. They help you digest food, generate a lot of the micronutrients that we don't generate in our own cells. The interplay between food, the bacteria, some environmental insults that we provide in addition to that, we feel quite comfortably are the initiating events for bowel cancer. So a healthy diet, reducing fat intake, all these things we know are part of it. And I guess the last thing I'd say is we're pretty confident that inflammation is in the background of a lot of what's going on. So chronic inflammation is associated with lots of increased risk of cancer across the spectrum. And those things are all together. So it's a zoo of things going on.
Yes.
But they are connected, and we do have the capacity to understand them.
Yeah. I mean, I've often heard the gut being referred to as the second brain, just in terms of the sheer number of neurons that are there, the bacteria, the gut cells, and the poor old gut really has to deal with a lot. I mean, it's the inside skin, really, isn't it?
It is extraordinary the way it communicates with the whole of the nervous system, the neurotransmitters which are generated by the bacteria, for goodness sake. I mean, they're just amazing. So
look, we could talk about this for a while, but
we could, yeah.
Look, on that note, I think it just leaves me to thank the audience for coming here, and hopefully you've learned a little bit about the patient side of things, the clinical trials that are available or ongoing or coming, the research landscape. And so thank you from the bottom of our hearts, Dorothy, Jeff, Lorraine, and Rob, for your time and dedication to changing the outcomes for people with GI cancers. And I'm going to wrap it up here. Just to let you know, for the audience, you will be receiving a survey, and be very grateful if you could fill that out. And for more information, you can find out how to support research to go to gicancer.org.au. Thank you very much. Thank you everyone for your time this evening, and we hope to see you soon. Bye for now.